Well, greetings, Mr. Colazar's class. Today we're going to talk our last section in section 4-5, the mass of the atoms. And our key idea we're going to be looking at is coming up is that idea of the isotope. And so what we're going to be looking at today is the idea that because the mass of the atoms in grams is so small, is difficult to work with, so the chemists have developed a new standard. Remember, one proton is equal to about 1.6 times 10 to the negative 24th grams. That's way, way too small for us to work with. So they've come up with what is called the atomic mass unit. We're going to abbreviate it AMU. And it's going to be the mass, what they found out is carbon-12. Carbon-12 has 6 protons and 6 neutrons. And remember, the mass of the electron, too small to worry about. So we don't actually include it compared to the proton-neutron. So they just took 6 protons, 6 neutrons, 12, and divided that number 12 by 12 to say that approximately the mass of one proton and one neutron would be one atomic mass unit. So the weight of one proton or one neutron is one atomic mass unit, so we have a comparative scale to work with. Now, what we're looking at is when it comes to those ideas, isotopes are going to be the same number of protons, for review, and different number of neutrons. So the mass of the element is different. Chemically, they're the same, so mass is different. And what we're going to look into is how to calculate out. And so the equation for this, the atomic mass, is a summation or the addition of all the parts of each of the mass contributions of each isotope. And so when we look at that, mass contribution is the mass of the isotope times its percent abundance. And so this is going to give us what we're going to talk about is a weighted average. A weighted average, instead of just being an average, is going to be weighted average because it talks about how much percent abundance does each put together. So each isotope mass times the percent abundance is what we're going to be looking into our equations. Now, to practice this idea, it says chlorine 35 has a percent abundance of 78.78%. And in this test, chlorine 37, a heavier isotope of chlorine, has an abundance of 24.2%. Calculate the atomic mass for chlorine. So we're going to start out your equation. The mass contribution is equal to the mass of the isotope times the percent abundance plus, and we continue that equation going for each part. So when we look at this one, our mass contribution, the mass of the isotope. So we have chlorine 35 is the mass of the isotope times the percent abundance, which in this case, you're going to turn percent into a decimal. So we're going to move from 75.8 to 0.7578. And you're going to take that and add it to the other mass of the isotope, 37, times the other percent, 2. Now, when we work through this, we get about 26.523 plus about 8.914 when those are multiplied together. And if we take the addition or add those two parts together, we get about 35.484 is my calculation for the mass of chlorine. So this is what we call our weighted average. The weighted average for each element is the percent abundance, how much you have of each isotope, times the mass of that isotope. And so when we add those two together, or three together, we would get the overall mass. This is the number that's found on the periodic table. So when you find this number on the periodic table, this number is slightly different than the one you have. That's 35.45. That's okay. That was just our calculations for what was given data-wise. So our second problem, given the data on the table, calculate the atomic mass for the unknown element X. So X is some element. And X has an isotope that's 6 and 7. So we have atomic mass unit of 6, atomic mass unit of 7, and their percent abundance is given. So our first step, mass contribution, mass isotopes times percent abundance. So remember to change this to the decimal. So 0.075 times 6, 7 times 0.9241. When we get those two numbers, the first one's about 0.454. The second one, 6.4787. When we add those two numbers together to get our weighted average, it's about 6.241. If you were to look on the periodic table, that element would be lithium. So lithium on the periodic table would be this element X. Now that's our weighted average. Now what we're going to compare, this is a key last one, mass number versus atomic number. Need to know the difference here. They're very similar. Mass number, number of protons and neutrons, rounded number. So we round that so you can find the number of neutrons. The average, the atomic mass then, is the weighted average of all of the isotopes. On the periodic table, this would be the decimal number. So this is the weighted average of all of them. Mass numbers once we've rounded it to find the number of neutrons. And that'll end our chapter 4. Oh, there's similarities between them. They're both talking about the nucleus, protons, plus neutrons in the nucleus. Got to give a similarity when we're comparing and contrasting.